Welcome everyone to an amazing open source Linux GNU FSF live stream. GCC 13 finally released today, and we had this prepared. So we are the first Linux distribution here with our increasingly amazing T2 just raw and working open source Linux to ship this. Yes, I know Fedora shipped it, but with a not final release candidate with, of course, some bugs fixed since then. So due to our amazing pre-testing and compiling RISC-V, PowerPC, Spark the last days, we can just commit that now. Let's do the work. And it's did I rediff everything? What did we? So hotfix. So this is modified. This is deleted. This is modified. Let's one final look whether... Alright, so this is a fix. That's not technically the same thing. We could commit this independently. Let's just... Also, this is not very... What do I have here? Oh no, I freshly rebooted for some reason. Like live streaming from Steam Deck. Previous video. Changed my setup now. I was tired of AM5 USB glitches. And... isochronous USB video audio drops. Also, I don't have my LED light bulb studio light not on. Yeah, so I hope the Steam is amazing. So that is also why Ryzen, Epic Threadripping Ryzen only is build server. So commit GCC just to make sure the copyright stuff is up to date. And then the conf, so that is basically, when in a previous video I thought LTO stuff was broken, this was only the LTO plugin didn't install because that was not using the same version. So basically our code relied on the T2 package version to match the GCC version, which just does not necessarily. So I now changed this to read the GCC based version here. So that is that of improved GCC LTO plugin installation. Use actual version. So version 2 with release candidates 2 or stuff. Just so it's not really strictly necessary, but it wasted some hour of me the other day, so why not make it better, right? I hope, like, make it better until it breaks, because only constant is change and regressions. Let's live. So pro tip, right? Always diff your stuff before, diff your shit before you commit it. What did we rebase here? All right, this was some Spark. This is optimization. What was the MIPS? What was that? Well, maybe it was also only some... Alright, this was the multi-lip stuff. Yeah, if I made there any mistake, we will notice later, so we can commit the rest. And yeah, so that is how quickly that goes if you spend hours preparing for that the other week. And then the only thing that is missing for us to release the next T2 version is .1, because only constants, change and regressions. We are professionals. We don't ship release candidate compilers nor .0 kernel versions, because there's always the next hotfix, like those here, like ASN1 fix check for string dub success. Oh my god, null pointer dereference. Single address space monolithic Linux kernel 2023. Cheers. Disable array bounds, GCC2, wonderful. Just what we need. Okay, dref, write back, C group, pointer, all the stuff you want in your production kernel. Then a synopsis, so that is another Ryzen, so nothing like local build here, build server there. And now also don't forget to check subscribe for a review of the first 96 gigabyte non-binary size, non-power of 2. I think do they call it non-binary? I really hate the non-binary name. DDR5 non-binary or stuff, because yeah, I mean, non-binary, this naming is like, this is the biggest bullshit naming I've ever seen. Like what is the freaking heck not binary on 0 and 1, and it's still binary, it's size, it's, I would call this not power of 2, isn't it? Isn't it non-power of 2? Why does the industry call it non-binary when it's power of 2? Yeah. But whatever, so 96 freaking gigabyte overclock to 6000 mega transfers, review coming soon. And that is also the, yeah, anyway, for exactly this kind of stuff. So we have some stuff to do. So so we SVN updated there. Let's rebuild. What should we first? I mean, we can actually commit the next thing, because on the build server I have some other stuff lying around. So basically, also a good time of merging my dozens of commits, also Linux kernel 6.0 already prepared, right? And 915 non-x86. The only Linux distribution shipping you DDR, like stable releases, SPD, DDR5, memory hub, EEPROM, and temperature support. Previous video. Intel i915 non-x86, RDNA 2, RISC-V, and the most amazing RISC support, which we need to tackle there a little bit. So yeah, need to merge some stuff here back and forth, and here I had actually some Go changes. You see, maintaining a tiny little hobby Linux distribution in your spare time actually keeps you busy 24/7. There's nothing like 9 to 5 in open source development. So I had some Go enablement here because we wanted to selectively disable that. This is also just some wording. Don't really need that's the most. So config, conf, and config in. Although on a quick glance, I think we could probably, oops, is it? Yeah, copy and paste like Vim, the most amazing editor, and copy and paste. Yeah, one line off. So I guess nowadays, oh wait, we could also probably do that here. Just Go is probably more important than Gnat, I guess. Why is there GNU NYU? Is it GNU NYU? Is that a, or is it a typo? No, here's GNU New Java. What? Yeah, okay, fine. It's probably not a typo. 2020, whatever, that was intentional. Good. So bool enable Go. So I might change that to chip ISOs like disable. This will be a second thing. I will probably change disabling that by default and shipping the not GNU Go but Go compiler by default, just so that the Go stuff actually builds like this amazing shell. Was it? What was the freaking name? Where did I even package it? Oh, let's check. How should we first? Like shells, crazy. The name was so crazy. I apparently. Where was it even? Oh my posh, of course, 2022, last year or so. People name open source packages oh my posh, but yeah, because that didn't build for me with GNU Go, so there goes that. Edit config option to disable GNU GCC Go. Oh, so yeah, of course the work doesn't stop there, so shipped it, that easy it is. You can SVN up and system emerge. Playing along at home on your SG Octane, O2, UltraSpark, ARM, RISC-V, PS3, or just latest thread ripping desktop. All right, actually this is a interesting. Where did I even, because that is, I didn't use the build servers most like this last day, so we probably can, for a test, wipe that entirely. Nothing like wiping all your precious build stuff, and maybe one quick glance what I actually had configured there. Build and ship it all script, of course, does it automatically. Just what are we test building? x86. I mean, I will, or will I? Actually, maybe I don't. Actually, do I have that here? And build all arch. Let's do it this way. Unmatched arch. I think I was so clever and used proper double dashes for this. Yeah, yet let's use just this, just so that I'm actually building our predefined release configuration, and then I could actually potentially ship it if it proves to be good enough. Some light today. It's a little bit. Light is light. Who needs light? So, but here we have some other stuff. Let's hope that is in a debuggable state, because at least this Rust configuration, we should also in springtime have papered serviette here. All right, let's somehow for PC 6432 temp fs. Why do we not? Here. Let's do that again, because I wanted to take a look at some Rust detail there for at least changed PowerPC default. So. I also rebuilt some stuff, amazing. So this stuff is the question. Something obviously breaks there, and the question is what? And that is the recurring theme, right? 2023, you need not only GCC, previously LM Clang, and now also Rust in your toolchain. Nothing like if you want a little bit fancy LVM2 stuff, like some provisioning and LVM cache, DM cache, then now you need Rust. So let's see what's going on there. Do we have Rust target? I believe. Okay, that is PowerPC. Does that, the question is, does Rust okay, this actually has host that. Thank you very much. Was it -- target maybe? Rust. Target and input file given this. Hello Rust. Okay, that does not start amazingly. Linking with CC failed. In generic elf. So this could be linking the wrong architecture. Yeah, file in wrong format. I really hate that they print here this elf hex value, so now you would need to look up somewhere, like in user include elf. Probably. Yeah, thank you much. So 20, okay, 20 is PowerPC. That is actually, at least that is correct. That the stuff doesn't print this verbosely. It's like why is it not printing? It's probably, which one is it using? It's actually using the wrong LDD. For some reason, should you not call it that way. Maybe it tries PowerPC, and we have Power. Actually, we have PowerPC. Maybe that is the issue. Maybe it's hard-codedly trying this arch prefix name. My life, how did I end up here? That might be the reason. We could find out, because I thought this should work like this usually. It's of course our, so we basically have this for PowerPC 32-bit, like only for some targets, right? In the meantime, we ship Spark twice historically. Spark 64 and PowerPC 64 defaulted to 32-bit user space for half the pointer size, improved performance, for better cache utilization and stuff. We could stride that f log of stuff, and it's of course a really PowerPC. So maybe this PowerPC T2. Okay, it does not try that directly. How do we try this best? The other thing I wondered the other day already, independently of this, we could very theoretically probably build Rust, so probably should put this on the to-do. Yeah, this is yet another to-do, nothing like too many to-dos. Theoretically, multi-arch Rust for 32-bit default targets. So basically we could probably build PowerPC and, should we write it properly, PowerPC and 64, so that both targets work. I have not tried this. I believe that, I mean, we do that for host and cross, for native and cross. I mean, they could still use, I mean, I could zoom link this. Maybe we check how this was built. It should probably have been. Yeah, PowerPC. So we already do dual target for, because we need to support native. At least I believe, as far as I remember. Actually, do we? Maybe for some reason we need it. Maybe it didn't build otherwise, or whatever. Or at least that is what the Rust bootstrap stuff did by default anyway, when you cross configured. So what we could do here is PowerPC and PowerPC 64 and the native variant. So how do we tackle that? So basically it's running the, what is even the error for building that? I mean, this is interesting that it at least, so I mean, this cargo build stuff starts to do something until it errors out here. So this atomic, I mean, maybe I should check. Did I actually check if it fails the same? Because I usually like to cross test. The only thing is it's computationally expensive in terms of spending electrons, good expensive electrons. Probably I need solar cells for that someday. Do I have here? No, I don't have that there. The question would be, is this, because this arrow currently looks like I might look manually running this, maybe running this with cargo somehow does something else for some reason. Maybe it uses CC then. So where is that coming from? Or does, maybe it simply doesn't. So the atomics are super annoying. Maybe actually this is simply not supporting 32 things, because the problem is 32-bit Spark then doesn't have 64-bit atomics, I believe. Maybe I'm debugging a dead horse here, and that will simply not just... And that is the thing with this modern Rust stuff, right? I probably should actually check that. The only problem is that will take a while to build. Ah, right, we don't need to clear something I don't have. So Arch PowerPC. Actually, was I so clever to auto default this to all if? No, so maybe I was. So yeah, this is the usual stuff. Why do I have so many horizons here? Because I need to test build and test build more. So basically the question would be in a pure 32, not changed default 64-bit build. Whether this fails the same, then it's not a using the wrong compiler, but simply Rust. I mean, probably 32-bit Power might not have then 64. Then we could PowerPC 64-bit atomics, but so now you would need to read the freaking manual. Atomics were anyway rather in 64-bit environments. So yeah, so much to that. In my opinion, it should also, I mean, previously the sim provision tools to build on 32-bit platforms, now the no new rewritten Rust code, not anymore, so there goes that. So now we need to wait a bit. Alright, we also had a Linux kernel to update actually. I think I didn't do that yet. Let's quickly pre-test if that all patches apply, then we don't need to test even more. Just I built this verbose here so that I control C more controlled when I see all the, so basically the patches all applied. Then it's good enough to ship that. Should probably not cause that many regressions, famous last words. Yeah, this unfortunately takes a while. But GCC is out. I read through the details, changes, the previous video, not really, I mean it's not that much deprecated. Senver 4, new Intel stuff, more of latest C23 or whatever, latest of more feature complete and details of C++. So usual improvements, better optimization, although some 5 or whatever slower compile time, but who cares about developers if the production code is 0.5% faster. I didn't want, alright, I wanted to check that, and okay, there are 1601. So yeah, that's probably it for this video. I need to wait for this build to check what, if the sim provisioning tools, do I have, so the only problem is on this here, I have a Steam Deck now. How much of this PowerPC did I build? Oh, actually, quite a bit. Nothing like live building on a whatever 15-watt AMD custom APU. But it can be done. Let's see where this build continues. So that is basically the 15-watt APU. Okay, this builds some stuff. Let's see what do thin provisioning tools do. Oh, they download. That is also good. It's a new release apparently. Thin provisioning tools. Nah, what? yesterday, probably already updated by our data. Yesterday was out. Release notes, but what do they usually change there? Fix Clippy lints for Rust 169. Oh, amazing. 104, what did they do? Ah, yes, 32-bit platforms. Fix compilation error on 32-bit write batcher. Hey, is it just what we debugged? Then we can. Oh, but should we not have that here? No, we have that here. It still failed. What does it do? Use associated seed type and corresponding different PRNG for pseudo-random number generator implementation. Small RNG different platforms, specifically the random seed. This doesn't. So they kinda support that 2-bit platforms, except that it failed for me. So Clippy lints, fixed typos, file permissions, incorrect CRC32 output for big Indian targets. So that is maybe Rust does not. Oh, this is some Git vendored. Like, yeah, 2023 people don't implement proper. It's like, yeah, Rust is not bug free, right? If you write logically incorrect code, it's still memory safe and it will output probably CRC32 endiness reversed. Here is more block get size 64. So yeah, they kind of support the two platforms, but maybe you need endiness, or there is some other cross compilation. Actually, here is some target pointer with stuff. Okay, so this fails the same as I kinda suspected, so much to their fix something for. Yeah, 2023 Rust is amazing and stuff, except you're still running 32-bit processors, like even this MNT reform, right? I guess that is because I just saw this scrolling by crowd supply. If you want this, not a paid advertisement, I'm not personally getting that because that is not my kind of thing. This might actually be the wrong thing, or is it? Is it the new stuff? Where is the freaking date? 2023. So that is the old. Where is the new? Here, version 2, maybe. Wherever. Yeah, wherever. This was ARM Cortex. Also, yeah, I'm not the greatest ARM fan. It's nice and all. I have some random stuff, but whatever. But so here is version 2 maybe, and where is the, why is this so strange everywhere you go? All I wanted is, anyway, my point was 32-bit. I believe that it's probably 32-bit. Whatever ARM Cortex A, whatever that was. I need some juice though. Pro tip, and not a paid advertisement, I fill this up with tap water. Nothing like some Mate Tea Schorle. Cheapskate edition. Half tap water. Then you only spend half the money and only need to carry half the stuff into the office. Amazing win-win. And hydration. So this fails the same for pure PowerPC, 32-bit PowerPC. Thin provisioning stuff. Wait, we built this with cargo. This cargo, whatever. Yeah, so much to fixed 32-bit. So that is in. Was it write back, cache write back? The only. So yeah. So then it's actually not our Rust stuff broken, but PowerPC 32 broken. Thank you very much. I mean, as a workaround, we could theoretically, if we had dual bit width support, we could fall back to 64-bit PowerPC. Common there, it's an ARM Cortex A72, wouldn't be the same processor. Pi 4, ATIC Cortex A20. So the promise with all this ARM naming is that for me it's always not visible, not immediately obvious which bit size that is. You're saying that, so that you're saying that ARM version 8 is yeah, that is actually 64-bit. Interesting. Didn't expect this, but nonetheless, the display. Like if this display would. But yeah, I also, long story short, I don't really need this, right? This. I mean, for some people, I only showed it. I said it right. It's not a bit address, but for some people, probably it's super amazing. I personally found although I have two super small display devices on my main channel, right? So OCO01. That I thankfully got relatively cheap on eBay some years ago when it was not that popular. I brought that for the transmitter Cruise CPU, and I have a Sony Vario P, previous very successful video on my main channel, and I found both the display with the OCO01 certainly the keyboard also, but with the Sony Vario P the display, and so basically I personally found I'm not very productive with such a small display, but for some people it's probably super amazing. Maybe for some road warrior users, maybe camping with it, or RF road warrior driving and all the other stuff. And I mean, at least the keyboard is probably larger than a Sony Vario P or OCO01 for that matter. So yeah, SynP here, right back. Oops, touched the mouse wheel and stuff. So that is exactly the same. Mapping counter. I mean, maybe it. I don't know for what other 32-bit platforms it builds then. I mean, this basically would need mapping. Where is this mapping counter? It counts the valid mappings in the metadata. So it matches. I wonder. Here is vcount load ordering sequence. I wonder what happens if we use 64Z232. If that would work as long as your mappings are not large enough. I don't know if that is functionally connected. I obviously would need to review that further. Also, yeah, Rust on a custom APU. I hope we don't get too many frame drops. So what are we building here, by the way? This was the PowerPC, so we can stop this, by the way. Save. Oh, what is happening here? Clang. Also, Clang failed somehow. What did fail there? So this could be memory instability. I freshly overvolted and overclocked this. So there's always a risk. I found recurring theme in a previous video. T2, one of the, like, if you want to test system stability. Hey, there's also release with the sec. Oh damn, I didn't fix the file. Fix it now. Nothing like doing that twice. And so what happened here? So if this randomly breaks, it might very well be what? That is a little bit suspicious. Using a reversed word invalid tree code not supported by dump declaration is very suspicious for maybe I overclocked the memory too much. There's always a thing that is certainly very disappointing because I need performance. So one reboot later. Let's end the recurring theme of like the risk of undervolting, right? Is it really worth it? Overclocking. Although for me, it is kind of worth it because this is only rated 5600, and with 5600 I lose too much performance. Even with this 6000 mega transfers overvolt, memory overvolt and overclock, I still lose 1.5% performance. So it's like if I would run this with 5600 or so mega transfers, I would probably easily lose 5% performance or so. And if you build 24/7 stuff like this, then it adds up eventually. That's also why I switched to my Steam Deck. I said this before, Steam Deck as workstation, why not? As a thin client, or even you can with just 3.5% CPU load live stream from Steam Deck here on T2 Linux, and then continue working while you reboot your systems while you fine-tune your overclock. Yeah, let's do that again because I was stupid. So that is, instead of fix file, usually use fix file. And so U64. That's of course. How do they load that though? That is count default. Probably was all. That probably was correct. Yeah, so yeah, I also don't know how to fix no. What is it? Atomic 64 patch or so. Atomics. And so we don't want to patch this for also, like for now, PowerPC. The only thing that's probably more, we need to see what happens on Spark or MIPS. Should we try rebuilding? I anyway need to rebuild the system compiler. Because I found currently somehow building GCC GNAT, the ADA translator, fails if you're not running the same version. I have not debugged why, if this is simply some path confusion or using system headers or defines, probably maybe, or just building ADA stuff with the system ADA compiler. Whatever the case might be. So we could use this as an additional stability test. I mean, maybe my system compiler, because I didn't use this slightly older T2 installation that much on this VM, just as a test before, because I don't really want to unclock my memory down that much more. There's also a hotfix patch cross already. What does that do? Ah, right, this was this silly thing. This was for right, this was for install running. Wait a second. I think we need this always, because even for native builds this will actually, or do we? I guess we want to never run that. can actually test that. Let's build this into the system. So what did that do? That also didn't build, which is a good indication for system stability. That might be, what old installation is that? 20, actually so new? Did I install such a new? Don't even remember that. Interesting, that must be when I wanted to release that. That really should not be that bad though. Or was it? Don't remember that. Yeah, probably don't run. How does this fail? Unknown print request, split debug info? What? Running cargo build release, error failed to run Rusty to learn about target specific information? What the heck? You had one job. Can't mix this stuff up, this is hilarious. What do I build here? Did I just build the wrong package? Where did I just build? No, here, whatever. Ah, right, image. Just built the wrong package. Let's try this again without the LTO just to be on the safe side.